folks, let's take a look at some very common factorings of binomials. So there's plenty of times where we have a difference of squares. You'll see something like a squared minus b squared, and it factors into conjugates, a minus b. Just to give you a quick and dirty version, right? X squared minus 25, right? 25 is a perfect square, so I can factor that into x minus 5, x plus 5. This difference of squares is probably the most recognized factoring formula out there. It pops up all the time. And if you were watching my video from example 2, we had something, well, let me give you another for example, right? If I gave you x squared minus 4, right? X minus 2, x plus 2, right? Conjugates. And we've talked about before how whenever you multiply conjugates, like if I was going to refoil this, outer and inner would cancel. Like outer would be positive 5x, inner would be negative 5x. Those would cancel. Outer positive 2x, inner negative 2x. Those would cancel. And just to kind of go back to my example from, or if you looked at my video in example 2D, we had something like x squared minus 5, which is also a difference of squares. We can write that as x minus root 5, x plus root 5. So this is just a very common factoring formula that's used. So difference of squares, if we recognize it, great. A squared minus b squared, go ahead and factor it. Just to give you a heads up, if you ever have a sum of squares, if I had x squared plus 25, that is prime. I can't factor a sum of squares. So that's why you don't see that formula here, right? You see difference of squares, difference of cubes, sum of cubes. You don't see, and I'll put it here, you don't see sum of squares because the sum of squares is always prime. All right, and on the upside, if you recognize you have a sum of squares, you can say like, peace out, dude, I don't have to factor this, it's prime, but it's a matter of recognizing that. All right, a cubed minus b cubed is a little bit more intricate. We have to factor it into two terms, right? This binomial and this trinomial. So it goes a minus b and then a squared plus ab plus b squared. And this trinomial is prime. So there's no way to break this down any further, right? A cubed plus b cubed is a plus b, a squared minus ab plus b squared. And how I remembered these is that if there was a minus sign here, there was a minus sign in the binomial and it flipped when you got to the trinomial, right? So minus went minus then plus. And if there was a plus here, there was a plus in the binomial, but a minus in the trinomial. Because these factorings are pretty similar, the only thing different about them is the signs, right? This is negative, this is positive, and this is positive, this is negative. So we're gonna look at the 4 examples here, and we're gonna line them up, right? We're either gonna have a difference of squares, a sum of squares, difference of cubes, sum of cubes. And just as we start to go through example 3, if we spot the sum of squares, we're done, right? It's prime. It's the other 3 that create more work for us. So let's take a look at 36x squared minus y squared, right? And just by nature of the fact that these are squareds, my spidey senses go up and I'm like, okay, I probably have some perfect squares in there. And then because this is subtraction, right? I'm looking at a difference of squares. So let's go ahead and let me make sure we can see this in the margin. So this one is going to be the difference of squares. So what I need to figure out is what is playing the role of A for this case. Oh, I don't think we can see the word difference. Let me just scooch this a little bit over here so that we have that. All right. So what is playing the role of A? What is playing the role of B, right? How do I rewrite this as a squared minus b squared? Because if I can figure out what my A and B are, then I can just rewrite, I can factor as a minus b, a plus b, right? I can factor into these 2 binomials. So if I think about what would square up to 36x squared, well, that would be 6x, right? So for this particular problem, A is being played by 6x. And then y squared is just y squared, right? So B is being played by y. So if A is 6x and B is y, and I break this into a minus b, a plus b, right? When I think about how I'm going to factor this difference of squares, I'm going to do a minus b, so I'm going to do 6x minus y, and then 6x plus y. And if I wanted to check myself, what I could do is I could FOIL this, right? Or I could distribute. You can do 6x times 6x, 6x times y. Negative y times 6x, negative y times y. right? And then when you collect like terms, you'll get back to 36x squared minus y squared. So it's like a check on yourself. You could also FOIL, right? First, outer, inner, last. It's the same thing as double distribution in this case. All right, and if you FOIL, you'll get back to 36x squared minus y squared, so you know you got it correct. All right, so let's take a look at B, right? First of all, I see the square, so I'm thinking, okay, I've got probably some terms that I can square here. Oops, let me go ahead and write some parentheses, didn't mean to give it away. All right, but take note, you have a plus sign, right? So this could be the sum of squares, and maybe we get a little hopeful because if it's a sum of squares, then it's prime. Well, what could square up to 4t squared? Well, how about 2t, right? Because 2t times 2t is 4t squared. What squares to 1? 1. So in this case, we do have the sum of squares, right? And we've recognized it. So this is prime. I can't factor it, which is great. I have less work to do, but I think it's sometimes more challenging in recognizing you have a sum of squares. But some of the clues are that I have squared terms and I have a plus sign, okay? All right, so let's go ahead. I'm gonna try and keep the cube formulas in view. I don't know that I can, so okay, it doesn't look like I can get all of this. So I'm gonna scooch this up so that we're seeing these terms, and then I'm gonna rewrite our cubed formulas just so I have them in the same view screen. So let's start with, I'll start with, if I'm looking at this, I'm hoping we can kind of see this is gonna be a sum of cubes. The clue here is that these terms are cubed, right? And then I have a plus sign here. So let me rewrite. If I had a cubed plus b cubed, that's gonna be a plus b times a squared minus ab plus b squared, right? So we'll just keep that in mind. And again, we're gonna be looking for what cubes up to x cubed, what cubes up to 343y cubed, because I would just wanna know what are my a and what is my b for this particular problem. So how do I relate this into something cubed plus something cubed? Now x cubed is just literally x cubed. And then we gotta think, what can cube up to 343, right? Y cubes up to y cubed, but 343, 7 cubed is 343. And you can check that on your calculator, right? You can do a little side check that 7 cubed is 343. I promise it is, but never hurts to check. And after you work with these cubes enough, you'll start to feel it out. Like it'll just become memory. All right, so this is gonna be 7y cubed, all right? So my a for this particular problem is x, and my b is 7y. All right, so I need to write my first factor. This is gonna be a plus b, so for here I'm gonna do x plus 7y, okay? Now the next thing says do a squared, all right? So I'm gonna do x squared minus ab. So I'm gonna do minus, a was x, b was 7y, right? Plus b squared. So I'm gonna do plus, and then I gotta do b, which was 7y, and I gotta square it, right? So just take a look at what I wrote, right? A plus b, a squared, minus ab, plus b squared. And then we're gonna PEMDAS this, right? So this is a linear factor, it's prime, right? So I'm just gonna rewrite x plus 7y. All right, we know x squared. Negative x times 7y is minus 7xy. 7y times 7y is 49y squared. And this trinomial is also prime. So linear factor automatically prime, trinomial whenever you're factoring out, and this is a sum of cubes. That back trinomial there, automatically prime. So we know we can stop there. All right, so on the difference of cubes, which is gonna be here, right? We know a cubed minus b cubed is gonna be a minus b, a squared plus ab plus b squared. So again, our kind of plan of attack is when I look at this, I see things cubed, right? And I see subtraction. Can I figure out what is my a for this problem and what is my b? So how can I rewrite this as something cubed minus something cubed? All right, and so this comes down to, do I know what number could cube up to 125? And it's 5. So this would become 5x, right? What number cubes up to 27? 3. So this is essentially 5x cubed minus 3y cubed, right? So my a for this problem is 5x. My b for this problem is 3y. And so I'm going to substitute in 5x here, here, here. And I'm going to substitute in 3y here, here, and here. And then we're going to simplify, right? So we're going to sub all of this in. So instead of a minus b, I'm going to write 5x minus 3y. There's my first binomial, which is prime. All right, then I need to do a squared, right? A was 5x, so I'm going to actually protect that and do a squared minus, JK plus, when I look at my formula, plus a times b, right, which is 5x times 3y, plus b squared. Okay. So again, for my particular problem, a was 5x, b was 3y. A minus b, a squared, plus ab, plus b squared. Right? We're substituting. And now it's a matter of simplifying. So I'm going to leave this 5x minus 3y. All right, 5x times 5x, right? I can think of 5x times 5x. That's going to be 25x squared. All right, 5 times 3 is 15, xy. And then I've got 3y times 3y. Well, 3 times 3 is 9. Y times y is y squared. That is also prime, right? In this particular problem, we had a difference of cubes. Right? So as we went through A, B, C, and D, we had a difference of squares, sum of squares, sum of cubes, difference of cubes, and we applied those formulas. So if I just scooch back down, right, those binomials, right, three of the, let me scooch even a little further just so we can see all of it. My bad. There we go. So those, well, really, there's three formulas, but if you think about sum of squares, right? Sum of squares is prime, difference of squares, really, really popular, common factoring formula. Then you got difference of cubes, sum of cubes. All right. Thanks so much, everyone. Bye.